Today I stumbled upon the following problem. Being given the reaction between hydrochloric acid and an alloy containing copper and zinc, we know that it is released a volume of 4.48 liters of gas in normal conditions. I remind you that normal conditions mean 0 grades Celsius and 1 atmosphere. Determine the mass of the alloy, knowing that with concentrated sulfuric acid there is liberated a volume of 6.72 liters of gas in normal conditions again. Okay, so before starting we need to know a couple of things. Copper never reacts with hydrochloric acid without a powerful current of air. So if we don't have this thing mentioned, we will skip it. So we will consider that copper doesn't react. From the alloys compounds, only zinc reacts. So the reaction will be as following: zinc plus 2 molecules of hydrochloric acid results zinc chlor zinc chlor 2 plus the hydrogen molecule, which goes out of the system. That means that it's a gas. So what we have is 4.48 liters of hydrogen, and we write it above the equation with zinc. Under it we will put 22.4 because this is the molar volume of 1 mole of any gas in normal condition. I repeat, 0 grades Celsius and 1 atmosphere. On the other side of the equation we write under the zinc 65, that is his atomic mass, and above it X, I don't know, unknown term. So to determine it we must do the calculations. 65 or 4.48 all divided by 24.4. We see that the result is 13 grams of zinc in the alloy. So because it isn't said the mass of the alloy, so that means that we can't just calculate the mass of copper by subtracting the mass of zinc from the mass of the alloy. We must write down the equations of copper and zinc with sulfuric acid, both the equations, because copper in this case reacts. We will have copper plus 2 molecules of sulfuric acid, resulting copper sulfate plus SO2 plus H2O, 2 molecules of H2O actually. And the reaction with zinc, zinc plus H2SO4, that means sulfuric acid, resulting zinc sulfate plus H2 that gets out of the system. So in order to calculate the mass of copper, because that's the thing which interests us here, we must calculate first the amount of SO2 from the reaction. We know that from the reaction there is 4.48 liters of hydrogen liberated from the second reaction, of course, and we will just subtract it from the total amount of gas. So we will remain with the amount of SO2. So the amount of SO2 is 2.24 liters. And making the calculations, I mean the stoichiometrical calculations, we have a total amount of 6.4 grams of copper. So now the only thing left to us is to add the amount of copper and the amount of the zinc. I mean 6.4 grams and 13 grams, and there will be the amount of alloy.